Yes, Shrishti, you can start.
Yeah. So good evening, everyone. I'm Shrishti and a very warm welcome to the 37th webinar from the TISCON e-Discovery series. Our guest speaker for today is Manoj Mittal, founder of Shelter Consulting Engineers. Manoj is an accomplished civil and structural engineering consultant with over 37 years of professional experience. An alumnus of BITS Pilani, he has handled over 1,000 structures of varying magnitude and complexities. He's a member of several professional bodies and is also contributing to various BIS technical committees. Thank you for joining us today, Manoj, and over to you.
Thank you, Shasti, for introducing me. And I will begin by thanking Tata Steel and TISCON for giving an opportunity to make this presentation. And I hope this presentation will be useful to everyone. And just a minute. Okay, so can you see my screen?
Yes, perfect.
Okay, right. So my topic is structural audit and interventions in buildings for seismic safety and processes and methodologies. So basically, this is very interesting and very complicated and very appropriate subject to explore and to understand for all civil structural engineers as well as to architects also to some extent. This area basically needs the understanding and the knowledge of the structural engineering fundamentals, construction technology practices, and also about the materials and the new technologies coming up in terms of retrofitting and various diagnostic tools also we need to understand. So it is a little complex area where you need to have a lot of experience and you have to understand several other aspects also. So with time, buildings are becoming complicated. My focus will be on the buildings and particularly mostly to the RCC buildings, although these concepts can be applied to other kind of buildings also. I will not be talking about the technology part. I will be talking about the process part. What is the process? How to go about the structural audit for any buildings and what kind of interventions we can make in those buildings for seismic safety. Now, when I'm talking about seismic safety, because this is the most critical and difficult aspect, but same principles more or less they can be applied to other kind of audit also. Because ultimately, when you do the audit, do the complete audit. It will include the seismic part also, the wind, the cyclone, and other aspects also. But this presentation is basically focused to the seismic part. And all of us, many of us might have done the structural audit and might be doing it. Some may be expert in this area also, but I believe that many of us will be new to this subject. So I will try to cover all kind of aspects which are involved in structural audit and interventions for buildings. Okay. Okay, just a minute. So how to just minimize this this sidebar? Can somebody tell me?
So click on the red arrow. Click on the red arrow, please.
Click on the red arrow.
Yeah.
Red arrow. Okay. So this arrow will hide. Okay. Right. So let's talk about first structural audit. What is structural audit? Structural audit is basically it is like a overall health and performance to assess what is the health and performance of a building at that particular period of time. So this is like a as we go for any kind of a medical test, regular health checkup. This is like a regular health checkup of a building. So it is based on well laid down computational procedures and to check the overall health of the building, and then we analyze and suggest appropriate repair, rehabilitation, retrofitting measures which are required, and then ensure that the building is safe and risk free. Basically, this is usually the purpose of any structural audit, to assess the present day condition of a building from a structural and seismic safety point of view. So let's understand the other terms also, when we say structural interventions, we have several terminologies like repair, rehabilitation, and retrofitting. Let's try to understand all the three terms. What does they mean actually? Because intervention means either you will be doing some kind of a repair, might be doing rehabilitation or the retrofitting. So repair is basically intends to improve the functionality of a component in a building that may have been rendered defective or deteriorated or damaged due to some reasons. And repairs are usually non-structural in nature, but if not attended, then they will lead to more serious implications with time. So if you attend it, repair it, then probably it will increase life, and it will prevent the further deterioration of those structural elements. So this is just repair. Repair, you cannot say that it is a structural intervention, but yes, it helps in structural safety. Then there's another term, structural rehabilitation. This is the structural intervention to improve the strength of the components of a deteriorated or damaged building. It intends to regain the original strength of those structural members. It is just to bring back any structural member to its original strength. And the term restoration is used interchangeably with rehabilitation. Generally, for historical structures, we can say restoration or rehabilitation. But essentially, rehabilitation means to bring the structural elements to its original strength. Usually, this is the meaning of the rehabilitation. Rehabilitation is a structural intervention. Repair is usually not the structural intervention, but it helps in structural safety to some extent. It will prevent the further deterioration. And then there is structural retrofitting. The most commonly used term is structural retrofitting. Now it aims to enhance the structural capacities like strength, stiffness, ductility, and stability of a building. It mitigates the effect of increased load demands, including future earthquakes. The term seismic rehabilitation, seismic upgradation, seismic strengthening may also be used instead of seismic retrofit. The building need not be damaged for the retrofitting, because if you have existing building, you can still retrofit for higher demands. If there can be several reasons for retrofitting, we'll see later also. But usually these are the terms which are being used: repair, rehabilitation, and retrofitting. So we say repair is not retrofit, but if you see this figure, on vertical axis you have performance, and on the left horizontal is the time, and you can see the repair. If you do the repair, the performance will not increase, but it will not deteriorate. But if you do the retrofit, whether it is a modest or comprehensive, it will significantly, you can see the arrow, small arrow, bigger arrow, it will significantly improve the performance of the structure. So retrofit will increase and enhance the performance of any structure or building. So why structural audit of a building? Why we need to do structural audit when it has been designed, constructed properly? So why we need actually structural audit? Apparently, if there is any distress in any building, any element, we need to think of structural audit. If there is a change in occupancy, suppose it was a residential building, it was designed, constructed as a residential building, now you intend to use it as a commercial or any other use, then you need to have structural audit whether it is safe to use for different occupancy or not. Then if there is a damage due to earthquake, fire, blast, cyclone, or any other accident, then also you need to do the structural audit. And then you might be having a building which has been designed properly, constructed properly, but now the earthquake, but now the code have been revised. So you might need to understand whether this building comply to the latest standards or not. For that purpose, also you need to do the structural audit. Similarly, structural changes. If you want to make some structural changes, for example, any vertical or horizontal additions in the building, then also you need to do the audit whether existing structure is safe enough to take the loads, gravity load or horizontal or earthquake loads, or any additions, or we should not do it. So basically, you need to do audit before doing any kind of additions or alterations of any kind. Similarly, extend the risk assessment of old important heritage buildings. If you have any old building, important building, then whether it is okay, there is no symptom, there is no code compliance issue, there's no any addition you want to do, but still you want to do the assessment of risk assessment of such kind of structure because they are old and they are important. There might be a structure which has been designed and constructed, but later on, even the new one also, maybe after a few years also, suppose it has come to your notice that there were some design errors or there were some quality issues in material workmanship or whatever, then still you want to do the structural audit before proceeding with any kind of a intervention. So there can be several reasons for, or there can be some routine structural audit also. Sometime any government authority may also make it mandatory. So ultimately, there can be several reasons for doing the structural audit of buildings. So when we talk about structural audit, the structure or building can be vulnerable to due to the structural design. It may not be done correctly. It may be site or location or soil specific, architectural shape and size, material which has been used, and the maintenance or construction techniques. So all these things make any structure vulnerable, and we need to take care of all such things in audit. So these are the few examples. You can see various kind of damages in buildings, and you can have n number of examples in your experience. So now we have seen we need to have structural audit. Why we need to have a structural audit? What is structural audit? What is repair, rehabilitation, and retrofitting? There might be some difference in opinion on the definition of repair, rehabilitation, and retrofitting. But whatever I have said, this is most commonly used. This most commonly understanding on this terminology. But doesn't matter. We will not talk about the process and methodologies of structural audit. Many of us might have done the structural audit or retrofitting and all those things, but it is very difficult to say what is the best way of doing it, whether we are doing it correctly or not. So sometimes we need to depend upon certain documents or standards or guidelines so that we are on the right track. So what I will do, I will just try to explain this methodology and process. There is a standard of BIS, which is IS 15988. So this is basically a standard on seismic evaluation and strengthening of existing buildings. So my presentation is usually based on whatever is given in this standard. Now this standard is also under revision, maybe in a year or so, maybe or earlier than that. There are maybe some changes in this standard, and so, but ultimately at present this is a standard on which you can depend for doing structural audit for the buildings. So what does it say? Now it says that you should have two type of evaluations, preliminary and the detailed one, because you cannot do the detailed evaluation for each and every building. Probably you may not need to do the detailed evaluation for each and every building, because detailed evaluation is a costly affair, time consuming, complicated, and each building may not need it actually. So if you can do the prelim evaluation and come to some conclusion, then probably you need not to do the detailed evaluation, but I will discuss both the steps. So we will start with the prelim evaluation. So what is this? It is a quick procedure to establish the actual structural layout and assess its characteristics that may affect its performance and vulnerability. So here we will be talking about, it's a quick procedure to check the layout and geometry and its performance and vulnerability. It is very approximate procedure based on conservative parameters to identify the potential structural risk of a building, and may be used to screen buildings for detailed evaluation. Now, if some building fails in this evaluation, then definitely we will go for detailed evaluation. If building passes in this evaluation, probably we will not go for detailed evaluation. Then it may, if the owner or client or user want to go for the detailed evaluation, you can go for detailed evaluation, or you can just stop at the prelim evaluation itself. Method is primarily based on observed damage characteristics in previous earthquakes coupled with some simple calculation. So it is a simple procedure to screen the building. So basically what we do here, number one, so first of all, you will do the site visit. In this prelim evaluation, you will do the site visit. Why you will do the site visit? To verify the available existing building data or collect additional data and to determine the conditions of the building and its components. It's a physical visual inspection. So what you will do, the checkpoints, you will see the number of stories, dimensions, year of construction, what are the framing plan, what is the lateral load resisting system, what is the diaphragm connection, wall, basement, foundation system. You will see the soil type, the building use, what kind of use it is undergoing, what is the nature of occupancy, what are the adjacent buildings, and whether there is a potential danger of pounding and falling hazards, whether there is a some kind of a deterioration in the materials or some damages, what is the extent of damage have happened due to earthquake, fire or flood, if there are any damages, if there are any unplanned addition or alteration or any undesirable architectural features, then if the soil is liquefiable and slope, all those things, or if there might be some, you will be looking for some visual distress symptoms like cracks, settlements, concrete spalling, corrosion, excessive deformation. All these things you can do by physical manual inspection by visiting the site. And even during this time, during this site visit, you can also try to speak to the people who were involved with the construction if they are available. You will also try to get the details, drawings, whatever they have. You can also try to see whether the drawing and site, whatever is existing at site, they are matching or not matching. So all those things are you can do during the site visit. Site visit is the first step, and I think this is the most important step to get the data, and whatever data you have, that you will like to verify from the site, from the existing building physically. So this is the most important step actually. And then how you will say that, okay, you have seen the site, you visited site, you saw all kind of a symptom, this, and then how you will say that my building is okay in prelim evaluation or not. So basically the standard 15988 says, and most of the provisions are something like IS 1893 part 1, which is a earthquake resistant design of RCC building. So it says that you need to do two kinds of checks. One is a configuration related checks. Now there is a strength related checks. In the configuration related checks, we need to examine the structural integrity like load path, redundancy, geometry, weak story, soft story, vertical discontinuity, mass irregularity, torsion, adjacent buildings, short columns, deterioration of the concrete or steel, mezzanine, loft or subfloor. So all those things you have to check. Now, if any of these things exist in the existing building, it means your building will need to undergo detailed evaluation. Okay. Similarly, you need to do the strength related checks. What are those checks? These are the quick checks to compute the strength and stiffness of the building components. What are those? Shear stress in RCC frame columns, shear stress in shear walls, shear stress checks in RCC, masonry, infill walls, and axial stress in moment frame. So these are the very quick steps how to do it, and this all need to be done within the for the prelim evaluation itself. And if your building passes through this, then it's okay. Then it's up to the owner or to you to go for detailed or not. Otherwise, you have to go for detailed evaluation. So we will see some of these checks how to do it. So basically, load path. In the load path, we say any structure shall contain at least one rational and complete load path for seismic forces from any direction, x direction, y direction. There should be one clear, rational, and complete load path to transfer the load. Redundancy, we say the number of lines of vertical, lateral load resisting elements in each principal direction, x and y direction, shall be greater than or equal to 2. At least should be 2 or more. Number of lines of vertical, lateral load resisting elements. Similarly, in case of moment frames, the number of bays in each line shall be greater than or equal to 2. Similarly, the number of lines of shear walls in each direction shall be greater than or equal to 2. Now see this is very simple. This can be checked very easily. You have a shear wall, whether there is only one shear wall on one side, that is not acceptable. So there should be at least 2 shear walls in each direction. It's a very common sense. So this can be checked physically by drawing by sight under this prelim evaluation. Then geometry, if there is a more than 50% change in the horizontal direction of the lateral force resisting system within the story. Similarly, you have to check the weak story, soft story. What is the weak story? They say the strength of the vertical lateral force resisting system in any story shall not be less than 70% of the strength in adjacent story. Soft story, the stiffness of vertical lateral load resistance system in any story shall not be less than 60% of the stiffness in any adjacent story or less than 70% of the average stiffness of 3 floors a story above. Vertical discontinuity, there should not be any vertical elements in the lateral force resisting, shall be continuous from the roots of the front, from the top to bottom. It should be continuous. There should not be any discontinuity. So all these checks we need to do in this mass irregularity. If there is a change in mass more than 100% between stories, then there is a mass irregularity. You have to go for detailed evaluation. Similarly, the Weissenberg torsion. The estimated distance between the story, each center of the mass and the story center of the stiffness shall be less than 30% of the building dimension at right angle to the direction of the loading considered. You need to check this. Adjacent building, you need to check this thing also. Similarly, you need to check whether there is any deterioration of the concrete or steel. If there are such symptoms, then probably you need to go for detailed evaluation. So all these aspects you need to consider during prelim evaluation by physical inspection at the site as well as by going through the drawings. But things becomes complicated when you don't have the drawings, structural drawings. So we'll talk about that also. So this is a geometry. I think everyone must have seen all those things. These are the geometries, good or bad practices. We all know we need to see all those things, whether this, what are the setbacks, what are the weak or flexible stories. Foundation is on the slopy ground. There is a problem, then you need to go for detailed evaluation. If there are floating columns, there is a problem. You need to go for detailed evaluation. If there's a discontinuity of the structural members, you can see there is a on the right hand bottom side you have a wall which is not going till bottom, till foundation. It is discontinuous. So these are any qualified engineer can make out all these such things. Soft story, redundancy, shear wall locations, I already talked about. Vertical discontinuity, discontinuity of the shear walls. These are all bad practices. If you see such kind of a thing in any building where you're doing audit, then definitely you need to go for detailed evaluation. This is mass irregularity. This is the distance between the two building blocks. There is a possibility that when the building was constructed, there was only one building block. Maybe with time there might some another building block might have been constructed later on, and the distance between the two might not be enough. So you need to check this also. This is about torsion. I was talking about center of the mass and center of the stiffness, and the recommended arrangements of shear walls. We all know about this. We also know about strong column, weak beam kind of a thing. This can also be, you can see. So that was configuration related checks. And now we should also do the global, this global strength checks. Now, what are these checks? Now, this is the expression given in this standard. It is F0 is equal to 2 by 3 VB by NF into H by L. H is the height of the total height of the building. L is the length of the building in the direction we are considering this. And VB is the base shear, and NF is the total number of frames in the direction of the loading. So what it says, calculate F0. I think VB can be calculated, and NF can be calculated, H and L we also know. And then if we divide this by A is basically the area of the columns, axial stress F0 by A in columns of moment frames at base due to overturning forces alone. So if you divide this F0 by A area, cross-section area of all the columns of the moment resisting frames, it says that it shall be less than 0.25 FCK MPa. FCK is the characteristic strength of the concrete, and 0.25 multiply that, and it should be less. If it satisfies this requirement, then we say it's okay. If not, then go for detailed evaluation. So this is a broadly approximate checks. Similarly, you can check the average shear stress in concrete columns, and it is NC divided by NC minus NF VI divided by AC, and FCK is a characteristic strength, and N is C the total number of columns which can be counted very easily, and NF the total number of frames in the direction of the loading X or Y, and VJ is the story shear at the level where we want to at any story where we want to calculate the average shear stress, and AC is the total cross-sectional area of the column. So this can be calculated very easily, not much computation, very simple, and it shall be lesser of 0.4 MPa and 0.1 under root FCK. I think this can be done. Similarly, this is on the right side. This is the average shear stress in concrete walls. It's not column, it is wall. It is VJ divided by AW. AW is the area, cross-section area, total area of the wall in the direction we are considering, and VJ is a story shear at that particular level, and it should be less than 0.1 MPa. So this can be done. These are the very quick calculation which can be done given in the code. After doing all those things, it says that go for detailed evaluation if building fails in preliminary evaluation. Means geometrical check, those configuration related check, discontinuity, and all those things, and then strength checks by calculating the axial stress, shear stress, and all those things. If the building fails in any of that, then it means you need to go for detailed evaluation. It also says that if the building is 6-story or higher, then definitely you need to go for detailed evaluation. Don't depend upon the prelim evaluation. If the building is located on the liquefiable soil or near active fault zone, definitely go for detailed evaluation. And if there's a building with inadequate connections or the joints, if the joints or connections are inadequate in any way, go for detailed evaluation. Don't depend upon prelim evaluation. So probably many buildings, when say 6-story, any building which is 15 meter or lower, probably many of the buildings can be checked with this approximate and simple procedure. And some of the buildings may be required to go for detailed evaluation. And if you want to go for detailed evaluation for any building, there is no problem that you can do. If you have time, you have money, owner wants it, you can do it. Okay, so now another important step is detailed evaluation, which we do most of the time for any complicated or any large building. So basically in this, we talk about the probable strength of the structural elements. We need to check what is the probable strength of the structural elements. It is determined and compared with the expected load demands. we calculate the expected load demand. We also calculate the probable strength of the existing structural elements. So it is like any structural design project actually. So another thing is load demands and capacities calculated by conventional means and applicable codes. Only thing given in the code here is that they are modified. Whatever the load demand and the capacities calculated by conventional means, which we usually do by 1893, 13920, whatever other standard by software tools or other procedures. Here we say that we need to modify them with appropriate knowledge factor K. I will talk about knowledge factor K. And then they also say the seismic demand shall be modified with usable life factor U. So there are two factors K and U which have to be applied to modify the load demands, seismic demand and the capacities. Then we also need to check the building components, check whether there is any deterioration of the concrete, cracks in the boundary column or diagonal cracks wider than 3 millimeter, and then we also need to check what is the residual strength of the materials, because somebody might have designed some structure or elements with some grade of the strength grade, and with over time you may not be having that strength. So ultimately we need to see what is the residual strength of the materials, and which can be tested by NDTs and another lab test. So this also we need to do. We need to see the actual strength of the material or element which we have, and we also need to see the deterioration, cracks, and etc. And we need to analyze the structure according to the condition of the structural element which is at present. And we also need to modify the capacities calculated by conventional methods and the seismic demand which we calculate from the codes, and we have to modify it with K and U factor, because we are talking about existing buildings which may have a different age. So we cannot see all buildings with the same thing, because it depends upon you how you want to see it, but the standard gives you this kind of an option. So this is a knowledge factor K. So what is knowledge factor? Knowledge factor says that you are now seeing the building. This is an old building which is occupied building, and you may not get the full data of the building. Okay, you may not have the access to the drawings, you may not be able to visit the site properly, all the elements, you may not have the design parameters of the existing building. So there are various knowledge factors associated with each kind of a condition. They vary from 1 to 0.5. 1 means whatever you are getting from testing and whatever, just consider 1. If there is some limitations, then multiply by 0.9, 0.8, 0.7, 0.6, 0.5. So ultimately multiplying the capacities of the element by 0.5, it means you are accounting for a knowledge factor. So for example, it says that if you have for example, say serial number 1, it says original construction documents are available, including post construction activities, material testing undertaken. It means you have every data available of the structure, then you say knowledge factor 1. And the last one is little knowledge of the details of component. You do not have the drawing, you cannot have any test data or anything, just take 0.5. Okay, so this is the knowledge factor which is applied to the capacities. And we all know this equation and this graph, we are all familiar with this to calculate. Then Z is zone factor, SA by G you can get, and T is the time period, and I is the importance factor, R is the response reduction factor given in the code. You can get everything from the code, but here we are multiplying it by U. Okay, so we are multiplying it by U. Now what is U? What is U? U is basically we are saying this under root of T remaining divided by T design. So T remaining is the remaining useful life of the building, and T design is design useful life of the building. So divide this by this and take under root. This will be the factor U, and you multiply whatever force you get, to multiply that by u. So ultimately this u will be less than 1. Okay, this u will be less than 1. So ultimately what you are trying to say, you are trying to reduce the seismic force by a factor u, and this factor u will depend upon the age of the building. If your building is old, then probably u factor will be less. If your building is very new, then u factor will be more. So horizontal force will be less for a old building. Horizontal force to be considered will be more for the newer building. But it also put a condition that u shall not be taken less than 0.7 in any case. If by this formula T remaining by T design under root, if it is coming less than 0.7, but you have to take 0.7 at least. So at least you have to design for 70% of the force which you are getting from IS 1893 at present. So this is the provision which you can consider in your design. So this I have talked about. So this way you can reduce the demand, and capacities you can always reduce the capacity by applying the factor k, that will vary from 1 to 0.5. So basically what we are doing, estimate the flexural and shear strength of the structural element member and joints as per the standard, as per IS 1893 and other standards, by conventional methods, by any method we usually do in our buildings, and then modify with the knowledge factor k, calculate design base shear and multiply it by u for analysis purpose, and then perform analysis, then make the mathematical model, do analysis, whatever else we do, and then check the acceptability of each component with the estimated probable strength of the member. Ultimately what we are doing, we are doing the same analysis, but what we have done, we are in the design, we will reduce the seismic load demand by a factor u. We will reduce the capacity by knowledge factor k. That will depend upon your situation. U will depend upon the age of the building. And then while doing the analysis, before that you will also do the other test, NDT other test, to check the residual strength of the material, concrete say. So whatever you are getting by entities or other thing, you will use that for your analysis purpose. And geometry, size, everything you will take as per the drawing or whatever is existing at site. And then you will analyze the structure as per the codal requirements, and then you will see which elements are safe, which are not safe, what is any inadequacy that you can do. This is the detailed part. Either now, after doing all these things, what you will see, we have to see that either of the two must be satisfied. All critical members have strength greater than the computed actions and drift checks are okay. If it's okay, all members are okay, right? If the members are not okay, some key elements, few elements are failing in these checks, then probably you need to go for non-linear analysis or pushover analysis to ensure that to ensure that failure of these elements will not lead to the loss of the stability of the or progressive collapse. So this thing we need to do. Ductility we have to see, NDT, detailed evaluation. Now as I already told you that we need to do certain NDTs, other tests. I will not go for, there are several tests, I will not go for this. Around our pulse velocity, pull out, core test. So once you have done all those things, your building, if say it's okay with prelim, and it's okay. If it's not, then come a detailed one. Even after detailed evaluation, you find that there are inadequacies in the members, then you need to do some kind of a structural intervention. Okay, so now that intervention will depend upon the kind of inadequacy you are having in your structural elements or system. So what are, I think we should focus on strategies. What are the strategies? Strengthening at member level, building with sufficient strength and stiffness at global level. Building is safe in strength and stiffness. but some elements may be lacking in strength or stiffness or ductility, or there might be some other issues with some elements. Then probably we can strengthen those elements by way of, say, jacketing or some other methodology. Then another strategy may be eliminating or reducing structural irregularities. Now, my structure might be having the issues because of the structural irregularities. What are those irregularities? We discussed earlier. Okay, they are mass irregularity, soft story, weak story, and all those things. They are all irregularity, discontinuity of vertical elements, all those things. So, if we can eliminate or reduce those structural irregularities, probably I will need less intervention in my structural elements. So reduction or elimination of irregularities related to the strength, stiffness, mass will reduce the seismic demand on other structural components. So if I can eliminate some of the irregularities, then probably the demand on remaining structural elements will reduce. So my structural intervention will be to the lowest possible. Our aim should be to do as little intervention as possible. So aim should be to reduce the gap between the center mass, stiffness, and all those things. So in this strategy, probably we need to add some braced frames and shear walls. If we can add some braces or frames, or we can have some shear walls in certain selected position locations. Probably by addition of the shear walls in some selected locations, the demand on other elements may reduce, and then intervention may be easier. Okay, so this is a strategy. Just we need not to do strengthen all the elements. We just need to think what is our strategy. Strengthening at the structural level, if the structure have more components which do not have adequate strength and ductility, then effective way may be to strengthen the structure to reduce the overall displacement demand. It may further enhance the force demand and some other elements. So if you are adding some element somewhere, and then again brace frame shear was again good supplementing damping and isolation. I think everybody knows that if we can add some damping devices, or we can have some kind of a base isolation, that will definitely reduce the demand on existing structural elements, and probably we need to do less intervention in existing elements. So these are the strategies. Okay, so I think we all know this thing. For example, if we can have something like this, it will enhance the addition of the shear wall. If we can add shear wall, if we can add braces, just some examples. So if you need to do some kind of intervention, I think I have only 5 minutes. So if we need to do some element strengthening, then column jacketing is one option, beam jacketing is another option, and then this jacketing can be with steel, beams jacketing with steel, carbon fiber wrapping, and then base isolation. We know we can strengthen the foundation also if required, and jacketing maybe with RCC steel profile sheet encasement, or wrapping with FRP. Deficient members must first be stressed relieved by propping. This is another important. First of all, where we want to do this jacketing or any kind of a strengthening, first of all we must relieve it by propping from the stress, and then do the strengthening process, and then we should remove the props. So I think I cannot go for these details of jacketing, but how to provide calculate the thickness of the concrete jacket and everything, this is all given in this standard. I think if you go for this standard, you can calculate some very simple things are given. I will not cover, time is not there. Okay, so these are the steps for different kind of a you can calculate thickness of the shear wall, reinforcement. Okay, so all those things are given in the standard, and bracings also, connection also, and there are other things also you can do. These are some visual pictures of doing goniting, or even you can do the repair and rehabilitation of masonry structures also, and there's another standard for that. Okay, so when to repair or rehabilitate or retrofit, usually there is no fixed rule for that, but we say that if retrofit or rehabilitation cost is less than 60 to 70%, except for heritage or historic structure, then I think we can go for retrofit or rehabilitation work. Yeah, because in case of his heritage or historic, you cannot put any such condition. And estimated time needed for implementation and disturbance to occupants in other factor which need to be considered while taking a decision whether to repair, rehabilitate or retrofit any structure. So basically, this is a standard which give you some kind of a guideline how to go about it, how to take care of knowledge factor, and all those things. And also, you can also need now to do the detailed evaluation for certain kind of a structure, certain situations. But it is up to you whether you want to do the detailed evaluation for all buildings or not. Okay, so this is usually the process, and then ultimately you have to prepare the report, you have to prepare the detailed specification for retrofitting, rehabilitation, whatever. And so I think I will end here, and if you have any questions, I will take the questions.
So should
Okay.
we conduct the 3 polls?
Yeah, so we can, okay, we can conduct 3 polls. Yes, have you got the results? You can conduct the 3
I'm
polls. Yes.
starting right now. I'm starting right now.
Okay, you can start the, so there is a poll. You can just see and you can answer it. In the meantime, I will take some questions. So, is there any question?
Yes, sir. After the 3 polls, Shrishti will be asking you selected questions.
Right.
Shrishti, you may ask the questions now.
Yes, I'll go ahead with them.
सर कैसा हालचाल हिंदी पढ़ रही
Peter, can you view the questions? I'm not able to see them on the dashboard.
Is it mandatory to do structural audit of the buildings? Vijash has asked this from Bombay.
Okay, so yeah, it is not mandatory to do it. Actually, National Building Code mentions that all important buildings should be audited, evaluated after every 5 years. But the thing is, unless until authorities make it mandatory, it will not become the mandatory. So ultimately, it is up to the user or the owner to decide whether he want to do the structural audit of the building or not for some reasons. Okay. So as such, there is no rule whether it is not mandatory. But for example, in Delhi, High Court after when a case was filed in the High Court, they made it mandatory for certain height of the building, certain age of the building that they need to go for structural audit and retrofitting of certain kind of buildings. So in general, it is not mandatory. It becomes mandatory only if some authority or government or department make it mandatory. As such, it is not mandatory.
Okay, thank you. The next question we have is, can I issue a structural stability certificate after retrofitting is done?
See, this is another very tricky question. I say something like that. If you go to any doctor and then you go undergo some health checkup and everything, and then you also suppose go undergo some treatment, can a doctor give you a certificate that now you are fit to live for so many years or something like that? I think nobody will take this kind of responsibility. But in India, for buildings, these kind of certificates are generally are being required by the different authorities for different purposes. Even owners also want this kind of certificate. So yes, I think in a present scenario, you will be required to give some kind of a certificate, but be very careful what you are writing and how you are writing. The language and everything must be very clear. It may be conditional, because you cannot take the guarantee or warranty of any building because you have made several assumptions and so many things. So you have to be very careful, but you will be required to issue such kind of a certificate, but be careful with the language and the wordings and what you are writing in it.
Okay. The next question is, are there any Indian textbooks available which explains various case studies of repair and retrofitting?
So textbooks are not, I have not seen any textbook, but I know there are several publications, even good publication. For example, there is one book, handbook on seismic retrofit of buildings. I think I have this one, if you can see this. So this was published by CPWD and Indian Building Congress and IIT Madras. So there is a no CPWD manual, a handbook on retrofitting and repair. There are other several such kind of books are there. Textbook is not there, but some handbook and guidelines are available. But still, see, you just you can understand certain things from these things, but each building, each case is unique. So ultimately, it is up to the engineer, the consultant, and the who is doing the audit. He has to decide himself how to go about it. But yes, something is given in these things. And also, I mentioned this is BI standard, and now BIS is also revising it, and they will be coming up with various standards on masonry, steel, and all those things. So we will have those kind of documents also with you.
Okay. The next question that we have is from Jagmohan, which he's asking, is there any way of improving the strength of structural members without jacketing? That is by just injecting the concrete members with chemicals.
See, yes. So basically, first of all, you have to see which element is inadequate, and then why. For example, if you have any member, say column or beam, which has strength less than the required. For example, you need to have M25 grade of the concrete for that particular element, and by core test or something you are getting less than that. Then you need to check why it is less. In certain situations, if you have density is low, there is a porosity, there is a voids in the concrete, because you cannot rely upon the core test only. You have to do other tests also, and you come to the conclusion that there is a porosity, there are voids, or there some kind of a density is low. So probably you can do the pressure grouting, you can inject the cementitious materials, you can inject the epoxy, you can inject the polymer something. So yes, by without doing the jacketing, by doing some kind of injection grouting of suitable material, you can increase the strength to some extent, I would say. But it's tricky. It's tricky how much material you are able to inject, and so. But ultimately, after doing all this, again do the test, and then yes, you can do some strengthening without jacketing also to some extent. And
Okay.
that technique is already used. That is used actually, and sometimes we use that in conjunction with the jacketing also.
Okay. The next question we have is from Dr. Subramaniam, where he's asking, with the change of IS 1893 every few years, structural audit may be necessary for all buildings. Is that true?
No, see, that I think standard will not make anything. This 15988 will not make it mandatory. Ultimately, see, I just highlight this one more thing. Any BIS standards are not mandatory as such. They are all recommendatory standards, but they become mandatory only when they are notified by some department or some authority. Only then they become the mandatory. So if your department, your organization, your government, state government, or some local government, municipal corporation of any authority or development authority, when they will make it mandatory, then it will become mandatory. Otherwise, all provisions of the standard as such, even after revision, it will not be the mandatory. But we need to promote it and make the people aware about the standards, and so that they start using it.
Okay. The next question we have is from Samruddhi. Is it possible to do retrofitting of a structure without hiring a contractor on site?
No. Ultimately, a structural engineer or any civil engineer, they will do the audit, they will analyze it, they will do everything, and then they will give you the recommendation how to go about it. But ultimately, somebody has to execute it, and who will execute it? Some contractor, but not the ordinary or general contractor, not the already or civil contractor. He may be a civil contractor, but he must be experienced in doing all these kind of a thing, because these are little specialized things. So you need to have somebody, some contractor who can execute whatever you have designed, whatever specification you have made, whatever details you have made. Somebody has to execute it. So you cannot do the retrofitting without a contractor, but contractor will not be a routine or general kind of a contractor.
Okay. Sridhar has the next question. Is there any certification required for an engineer to structural audit of building in India?
As such, no. But see, this is a very complicated area actually. As such, in India, we do not even know who is an engineer or who is not, and we do not know who is a good engineer and who is a bad engineer. So there is no law, but some of the authorities, for example, in Haryana or some authorities make it. They prescribe certain qualifications based on academic qualification and experience, who can do the structural audit, and who can certify. So that is only from the point of view of government authorities. If the government is requiring you to submit the audit report, then probably you need to have that kind of a qualification and experience, so that your certificate is valid in that authority. Only then it is there. But that is also there in some of the authorities, not very few, not much. So, but otherwise, if you have a genuine owner, and he want to have a structural audit, and so there, as such, for him there is no qualification required. Any good structural engineer having experience and having understanding of all such aspects, and know how to, and who knows how to do the structural audit and who understand all those techniques and things, he can do such things. But from government point of view, authorities point of view, in some cases some qualification experience is specified, and if you fulfill that, you can do it.
Okay. So unfortunately, because of lack of time, this is the last question that we'll be taking up.
Okay.
The question is from NC Balaji. What will be the fees or charges for structural audit? We don't have any kind of standard pricing in India.
True, we do not have any we do not have any fee scale, standard fee scale for the structural design itself. So talk about the audit. So no, there is no such standard fee scale for doing the structural audit. It will depend upon you, how much time you have to devote on that particular work, how complicated the thing is, and how much effort you need to put in that activity. So it depends upon you, and fee may vary person to person, consultant to consultant. At present, I don't think there can be any standard fee scale also. So it varies a lot.
Okay. Thank you so much, Manoj sir. And everyone who sent us their questions who we could not answer due to lack of time, will please write to us and we'll definitely get back to you with the answers to those. And thank you, Manoj sir, once again for having, taken the time out to conduct this session. And thank you to everyone who's joined us today. And keep looking forward to the next set of sessions that we come up with the TISCON e-Discovery series. Thank you so much. Thank you, everyone.
Thank you.